Hello, welcome back to Chapter 10, Section 3, Data Distributions. And in this video, we're going to talk about making a graph called a box and whisker plot. There's a lot of steps to this. However, none of it is that difficult. The only thing you're going to have to do mathematically, and I'll just put it at the beginning, the only thing you're going to have to do mathematically is you're going to have to put the numbers in order. And for this example, the numbers are already in order. When I do this one, we'll have to do that. And then you start finding medians. The thing is that you're first going to find the median, the middle of the entire data set, and then you're going to find the median of the lower numbers. And when I say lower, I mean smaller. And then you're going to find the median of the upper numbers. Now there's 5 numbers that are important. The 3 of them that I have here are 3 of them. The other ones would be the minimum, which is sometimes called Q0, and the other one is the maximum, so we want to basically know where the edges are, which is sometimes called Q4. So Q0 says I'm going to start at 0, and I'm going to go from 0 to 1. So I get the first quartile. Then I go from 1 to 2, Q1 to Q2, that's the second quartile. Then I go from Q2 to Q3, that's the third quartile, and finally Q3 to Q4 is the fourth quartile. So what I have are 5 numbers that are on the boundaries of 4 sections. Quart, Q-U-A-R-T, means 1/4. I've divided the data into sections that are all equally numbered, and then we got to figure out what the range is going to be for each of them. All right, there's a couple other things we're going to talk about. We'll mention this. I'll leave this up here too. Again, like we said, the range is the biggest number, subtract the smallest number. So the range of this data set would be 8. 9 subtract 1 would be 8. But we also have something called the inner quartile range. And that sounds complicated, but it's really not. It's still a range. The inner quartile just means if I go to the inside, that's my inner quartiles. So the inner quartile range would be 7 subtract 3, which gives me 4. And both of these things are setting us up for more advanced math. You've heard me say that before, where if you remember from the previous video, we had extreme values which affect the mean. Well, these are called outliers. And using the IQR, the interquartile range, there's a way to calculate whether or not a data point is an outlier. We're not going to do that in this step, okay? That's a few steps down the line, but I just want to mention that when we start talking about introducing IQR. All right, so here's what we got. So we got runs scored by softball team in 19 games. The first thing we need to do is we need to put these numbers in order. So all these numbers are positive because we're counting the number of runs. I don't see 1 anywhere. So I do see a 2, and I don't see any more 2s. And by the way, if I make a mistake doing this, I'm doing this like, I'm not editing this, so if I make a mistake, it's okay. I'm going to do that so you can see that sometimes you do make a mistake. So I don't see any more 2s here, but I have 1, 2, 3 3s. And I'm kind of lining these up so that if I get over here and I'm out of space, or I don't make it enough, or I go too far, then that means I did something wrong. Let's do some 4s. I got 4, 1, 2, 3, 3 4s, 4, 4, 4. Here's a 5, 1, just 1 5. I don't see any 6s. Here's a 7. And let's see, 8. I got 2 8s. I know I got some 9s in here, so 1, 2 9s. I got 1, 2, 3. I got 2 10s. Sorry, I started to say 3. That would be confusing, I'm sure. Here's an 11. And let's see, here's a 12, another 12, so a couple of 12s. and I got a 14. So see, by writing it to where I lined up all the commas, I know I have the same number here that I have here, which means that I didn't skip any and I didn't put any in there more than they needed to. Okay, so first thing is I got the numbers in order. Good. Now what I want to do is I want to find the minimum. I'll just say MIN for minimum, Q1, which is the first quartile, the median, Q3, which is the third quartile, and the maximum. And keep in mind the minimum is Q0, but we just say minimum. Median is Q2, and maximum is Q4. So it's Q0, Q1, Q2, Q3, Q4. Okay. The minimum and the maximum are easy. So I've got 2, which is the minimum, and 14, which is the maximum. So that's okay. Now we need to find the median. So what are we going to do? We're going to count. And I normally wouldn't write this, but I'm going to write it so you can see what I'm thinking, okay? So I got to be cautious because I'm going to count, but I'm going to show the numbers that I'm counting. Those are not part of the data set. They're actually the position. So this is the first number, second number, third number. So I'm going to keep counting: 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and yes, there are 19 games there. Okay, so that right there, those are not the numbers, those are not the number of runs, it's just the position. 7 is the 9th number, 10 is the 14th number, and it's also the 15th number. So how do I find the median? I want to find what is in the middle, position-wise, between 1 and 19. So I do 1 plus 19, which is 20, and 20 divided by 2 is 10. So I need to find the 10th number, and that's 8. So my median is 8. Now here's the cool part. If I had crossed things out to get to the 8, I've wiped out all my numbers. I want to be able to see my numbers. So I'm not going to cross things out. Here's the cool part. Now I'm going to, better use a piece of paper. I'm going to cover up the median and all the numbers that are bigger than the median. And I'm just going to look at the first through 9th numbers. What number is in the middle of this group? All right, I need to write, so I'm going to put this back. So I do the same thing. I do 1 plus 9, which is 10, and 10 divided by 2 equals 5. So now I'm going to look for the 5th number, and that is my first quartile. The 5th number is 4. That's why I wrote a 4 there. Don't write 5 there. That's just the position. Then I do the same thing for these numbers. I cover up the median and all the numbers that are less than that. I've got the 11th number to the 19th number. So I do 11 plus 19. That's 30. 30 divided by 2 equals 15. So the 15th number is 10. So that is how I get my 5-number summary. However, what I don't have is a box and whisker plot. So usually when we try to do this, try to give some graph paper. But we're not going to use graph paper because you may not have graph paper at home. So here's what we're going to do. We're going to draw a number line that represents the range. It has to go from 2 to 14. And I'm just going to sketch it here. If I need to change it, that's fine. Here's 2, and I won't number all of them. That'll be 3, 4, 5. I'll do 5. 6, 7, 8, 9, 10. Here's 10. 11, 12, 13, 14. There's 14. And we'll do 15 and 1, just because we like to. I like to have a little margin on it. Okay, you don't have to go all the way to the edge. All right. The minimum and the maximum are going to be represented by dots. You can also draw lines, but usually you're just going to see them as dots. And I'm going to put it in this space, okay? I'm just using my number line to line everything up. It's kind of a guide. It's kind of like putting your ruler next to things, but you're not actually going to put the stuff on the number line. This is why using graph paper is a little bit better, but like I said, this will be okay. So the minimum is 2, and I'm going to put a dot right here at 2. And I got to label it. My maximum is 14. Here's 14. I'm going to put a dot right here at 14, and I'm going to label it. So I got that going on. Now the next 3 numbers, I'm just going to do the same thing, except this time I'm just going to draw like the edge of a rectangle. So let me show you. Q1 is 4. So here's 2, 3, 4. Here's 4. So I'm going to draw the side of a rectangle right there, and I'm going to label it. I can put it at the top or bottom, so I'll put it at the top. The median is 8, so here's 5, 6, 7, 8. Here's 8. Again, graph paper makes this a little bit easier, but it's okay. And Q3 is 10. Here's 10. So I'm going to draw this like this. So I got dot, line, 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 dot. All I have to do to finish it up is draw across the top and bottom of this box. I've made a rectangle with a line somewhere in the middle of the rectangle that represents the median. That's the box in a box and whisker plot. The whiskers look like this. Now what this does is that it gives us a way of representing where the numbers are clunking together, clustering together. This data seems pretty kind of spread out. They've got a lot of games where they scored 2, 3, and 4 runs. That's from here to here. Then they've got some data where they scored from 4 to 8 runs. That's from here to here. Then they got some where it scored 8 to 10 runs. That's from here to here. And then the last quarter of them goes from 10 to 14. That's from here to here. So the closer these things are, that means that the more the data is clustering. This half of the box is twice as wide as this half. So from 8 to 10, they've got 8, 8, 9, 9, 10, 10. There's a lot of games where they scored 8, 9, or 10 runs. Same thing here, 2, 3, 3, 3, 4, and even 4 and 4. There's a lot of games that were down here. Okay? So that's how we do a box and whisker plot. And actually, I should also title it so I can say number of runs for this softball team. All right, let's do another one, and you can always rewind and watch these videos again, and I'll be doing more examples in the example problems later. Okay? We're going to use this data to make a box and whisker plot. This one didn't give me a story with it, okay? So the first thing that we need to do is we need to put the numbers in order again. I don't see anything less than 10, so I'm going to start with the 11, and I don't see any more 11s. So any 12s. Here's a 12, I got 2 12s. I got 1, 2, 3 13s. I got 14, 14, 14. And hopefully I don't mess up, but if I do, it'll be okay. Here's a 15. That's the only 15 that I see. I don't see any 16s. Here's a 17. I know I got a couple of 18s. Here's a 19. Oh, and this is nice. 22 and 23 there at the end. And again, all my commas matched up, so I know I've got the same number. Okay, now, again, this is not something I would normally write if I was doing the problem, but I'm going to do it so you can see what I'm thinking. I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So this is what we call the position. So the first number is 11. The 7th number is 14. The 13th number is 18. That's all that means. Let's find our 5-number summary. And there's nothing special about the way I do it. It's just, this is how I kind of got used to showing students how to do it. So the minimum is the smallest number. That's going to be my 11. The maximum is my biggest number. That's 23. That shouldn't be too difficult. Now let's find the median. What number is going to be between 1 and 16? So I do 1 plus 16, which is 17, and I'm going to divide that by 2. That's going to give me 8.5, or 8.5. So the median is going to be between the 8th and the 9th number. The 8th number is 14 and the 9th number is 14. My median is going to split those two right down the middle. Now, if they were different, I would add them together and divide by 2. I can even do that since they're the same. 14 plus 14 is 28, and you'll notice 28 divided by 2 is 14. So since both of these are the same, that's going to be my median. Now, for the first quartile, I'm going to cover up the bigger half of the numbers. So what number is in the middle here? So again, I think 1 plus 8, I'll write it down once I move the paper. 1 plus 8 is 9, and half of 9 is 4.5. So it's going to be between the 4th and 5th number. So just like last time, these are all both the same. So now my first quartile is 13, or 13 plus 13 is 26. 26 divided by 2 is still 13. Now I'm going to cover up the lower half of the numbers, and I said I'd write it, so even though I'm done, I'll do it over here, because when I take the picture, people will be confused if I don't. Okay, now what number is between the 9th number and the 16th number? I do 9 plus 16, which is 25, divide by 2, and I get 12.5. So it's between the 12th number and the 13th number, which again, both of these numbers are the same, so that's going to be 18. All right, now I need to draw my box and whisker plot. Again, graph paper would be nice. I don't have graph paper to use, so I'm going to draw a number line. The number line has to include 11 to 23. So like I said, I like a little some margins on my graph. So I'm going to start with 10, then I'll do 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So everything from 11 to 23 should also be between 10 and 25. And this is not even part of the graph, it's just guidance to help me draw the graph. My minimum is 11. 11 is right here. I'm going to make my dot at 11, and I'm going to label it. My maximum is 23. 23, here's 21, 22, 23. So I'm going to make my dot right here. Hopefully it's about the same, and I'm going to label it. For the other three numbers that represent the inner quartile range, I'm going to find the position on the number line, and then I'm going to draw like a vertical line segment. So here's 13. 13 is going to look like this. Let me label it. Here's 14. 14 is right next to it. And remember what we said, that the skinnier the area, the narrower the area, that means that the numbers are clustered in there. So I've got like 13, 13, 14, 14 for that one. The fourth quartile, 18, here's 15, 16, 17, 18. That one's going to be right here. And we're going to label it. So now all I got to do to finish my box and whisker plot, draw the top and bottom of that, and then draw the whisker part, just like that. And this data doesn't really represent anything, it's just some numbers for practice, so we're not going to give it a title. We'll see you in the next video.